Every major automaker is racing to match Tesla's performance, but none of them have figured out what's really powering Tesla's lead. While companies like Ford and GM are still stuck solving problems with heat, weight, and wear, Tesla took a different route entirely. Inside their motors is a carbon-wrapped rotor, an innovation that quietly fixes the core design flaws every other EV still struggles with. It's not just a better material, it changes what an electric motor can do. And it's the reason the Model S Plaid outpaces million-dollar supercars. So what exactly did Tesla figure out that the rest of the industry overlooked? And why does this one breakthrough push everyone else years behind? Every electric car on the road today has a fatal flaw that engineers have been hiding from you for decades. The problem isn't in the batteries or the charging systems. It's buried deep inside the motor itself, where a spinning metal rotor creates forces that destroy efficiency and limit performance in ways most drivers never realize. Traditional EV motors use metal rotors that seem perfectly fine on paper. These dense steel or aluminum cores look solid and reliable in engineering diagrams. But when you spin them at the extreme speeds electric motors demand, physics takes over and reveals their fundamental weakness. The faster they rotate, the more they work against themselves. As traditional electric motors spin faster, they heat up. And when metal gets hot, it expands. That might sound small, but in a high-performance motor, even tiny changes matter. The rotor swells just enough to throw off the perfect alignment engineers carefully designed. When that happens, the motor wastes more energy and loses up to 15% of its efficiency. It doesn't stop there. Inside the motor, magnetic fields are constantly shifting to create motion. But these same fields also trigger small electric currents inside the metal. These are called eddy currents. Eddy currents create even more heat. It's like the rotor is fighting itself, spinning hard while stuck in something sticky. The faster it spins, the more heat it creates, and the more it heats up, the worse everything gets. Because of this, most EV motors hit a wall. Push them past a certain speed, usually around 12,000 revolutions per minute, or RPM, and things start to break down. Efficiency drops, parts strain. Engineers have tried adding cooling systems or using special metals, but those are just workarounds. This is more than just a performance issue, it's a roadblock. Many popular EVs, from the Mustang Mach-E to the VW ID.4, face this same hidden limitation. The more power you want to squeeze out, the more you run into the same physics problem. Heat leads to expansion, and expansion kills efficiency. For years, it looked like there was no way around it. The rotor had to be made of metal, because that's what conducts electricity. So, automakers just accepted the trade-offs. Tesla didn't. Instead of trying to fix just the symptoms, Tesla found a way to remove the root problem entirely by borrowing a material and an idea from the aerospace world. Tesla's engineers turned to a material that most automakers wouldn't even consider: carbon fiber. Not just because it's lighter than metal, but because it changes how electric motors behave at high speeds. Here's why it matters. Unlike metal, carbon fiber doesn't interfere with the motor's magnetic field. That means less drag, less heat, and more energy going into motion instead of being wasted. Since carbon fiber isn't electrically conductive, it avoids the energy losses caused by eddy currents, the tiny swirling currents inside metal that act like hidden brakes. It's also insanely strong. Tesla's rotor spins faster than any other EV motor on the market. At those speeds, the outer edge is over 67,000 times the force of gravity. Steel would tear itself apart. Carbon fiber holds. It's about 6 times stronger than steel and much lighter, which is exactly what you want in something spinning that fast. And there's another advantage. Carbon fiber doesn't expand when it heats up. In a regular EV motor, rising heat causes the metal rotor to swell, throwing off the precise tolerances between moving parts and reducing efficiency. Carbon fiber stays stable, tight, efficient, and predictable, even under extreme stress. To make this work, Tesla didn't just buy parts off a shelf. They built a custom machine to wrap the carbon fiber around the rotor at exact tension levels, a process no other automaker had cracked. The wrapping has to be perfect. Too loose and the rotor fails. Too tight and it shatters. Tesla figured out that sweet spot. All of this adds up to a motor that runs cooler, spins faster, and delivers more power without compromise. That's why the Model S Plaid doesn't just launch off the line. It stays fast, even under stress, without the overheating or performance throttling that limits every other EV on the road. But as you're about to see, solving the motor wasn't the only breakthrough. This was just the start. It might sound easy. Just copy the carbon fiber rotor and match Tesla's performance. But that's not how this works. What Tesla built isn't just a new part, it's an entire system built to support it. What do we mean by that? Most car makers can't pivot that fast. Their factories were designed around old materials, old processes, and suppliers that aren't set up to handle a carbon-based future. Companies like Ford, GM, and Volkswagen rely on third-party suppliers who've spent decades perfecting metal motor production. They're locked into contracts, equipment, and systems that would have to be torn apart and rebuilt from scratch. Tesla avoided all of that by doing things differently from day one. They built the tools. They built the machines that build the tools. Every step of the rotor's development, from the carbon fiber itself to the machines that wind it into place, happens under Tesla's roof. That level of control lets them test, tweak, and scale up new designs faster than anyone else in the game. Other companies would need years just to catch up to the starting line. By the time they are ready, Tesla may already be on to something new. Tesla didn't just choose a better material, they had to invent the process to make it work. Winding carbon fiber around a spinning motor requires absolute precision. If the tension is too loose, the rotor fails at high speeds. Too tight, and the fiber breaks during manufacturing. Tesla solved this by acquiring a German engineering firm and building their own custom machine, one that winds the fiber at exactly the right pressure and placement. It took years to perfect. For competitors, catching up isn't just difficult, it's structurally out of reach. 3 major barriers stand in the way. First, supplier pushback. Most traditional automakers rely on outside motor suppliers who resist change to protect their investments in metal rotor production. Second, factory limitations. Rebuilding even a single production line for carbon rotors can cost hundreds of millions and take years. Tesla, by contrast, redirected in-house resources without waiting on anyone. Third, precision manufacturing. Carbon fiber demands a level of cleanliness and process control most factories weren't built for. Tesla already has that infrastructure, thanks to its battery lines. Even if a competitor invested today, they'd still be years behind. Tesla's team already climbed the steep learning curve, figuring out how carbon fiber reacts under intense rotational forces, refining custom resins, curing techniques, and quality checks. Others would need to start that journey from zero. So, when a rival claims they're working on a carbon rotor, what they're really facing is a manufacturing wall. The challenge isn't just building the part, it's everything around it. Tesla solved that puzzle long ago. And the carbon rotor? It's more than a better motor component. It's the first visible sign of a much larger shift. Tesla's new motor works in sync with the company's battery tech and AI systems to create a level of performance the rest of the industry hasn't caught up to. While other automakers focus on improving individual parts, Tesla designs the entire system to function as one. The carbon-wrapped rotor boosts efficiency by cutting heat loss. Less energy is wasted, so more of it goes straight into motion. That's a key reason why the Model S Plaid can hit supercar speeds and still deliver close to 400 miles of range. The battery isn't working harder, it's working smarter thanks to the motor design. Tesla's software plays a major role too. The company collects driving data from every vehicle on the road. That data feeds back into the AI, helping it fine-tune motor performance based on real conditions. When you drive up a steep hill or accelerate out of a sharp turn, the motor already knows how to handle it because thousands of Teslas have done it before. The result is responsiveness that feels natural and instant. No lag, no guesswork, just smooth power exactly when and where you need it. And because the system updates over the air, your vehicle keeps improving long after you've driven it off the lot. Better torque control, sharper acceleration, improved energy management, all delivered through software. Legacy automakers can't match this feedback loop. Their systems rely on isolated testing and slow development cycles. Tesla, meanwhile, is learning from millions of real-world miles every day. This is how Tesla builds its vehicles. Batteries, motors, software, and sensors are developed in-house and manufactured side by side in the same gigafactories. That integration allows changes to ripple through the entire system, enhancing not just one component, but the overall driving experience. Tesla doesn't treat performance, efficiency, and intelligence as separate goals. They're connected, and the longer this system runs, the more advanced it becomes, widening the lead with every mile driven. Tesla's carbon-wrapped rotor is so much more than a small upgrade. It's a ground-up rethink of how electric motors should work. It tackles the core problems that have held EVs back for decades: heat, drag, and mechanical limits. The result is a leap in performance, efficiency, and durability that wasn't possible just a few years ago. Tesla's lead in the EV race is about more than just being first. It's about building deeper, smarter, and faster. Their control over manufacturing, software, and motor technology creates a self-reinforcing edge. Every innovation strengthens the next. While rivals chase electric goals with fragmented systems, Tesla's all-in-one approach compounds its advantage with each passing year. The carbon-wrapped rotor is a signal flare, a clear warning that Tesla isn't playing catch-up because they were never behind. And for everyone else trying to close the gap, the road ahead just got a lot steeper. If you found this eye-opening, hit like, subscribe, and let us know in the comments what you think Tesla's next surprise will be.